Molecular theory of matter. Force of attraction exists between molecules of matter. The force could be cohesion, adhesion, surface tension, among others. Cohesion is the force of attraction between molecules of the same substance. Adhesion is the force of attraction between molecules of different substances. For liquids that wet glass, such as water, the adhesive force is greater than the cohesive force. Surface tension is the force at the surface of a liquid which causes it to behave like an elastic skin. Because of this force, insects walk on ponds and needles float on the surface of pure water. Capillarity is the tendency of a liquid to rise or fall in narrow capillary tubes. Liquids that wet glass rises in capillary tubes, while liquids with high cohesive force exhibit capillary fall. Diffusion. This is the tendency of molecules of a substance to mix with one another and fill empty space as a result of its constant random motion. The rate of diffusion depends on the nature of the substance, density of the substance, the temperature, among others. Example 1. If a beaker is filled with water, it is observed that the surface of the water is not horizontal at the glass-water interface. This behavior is due to A. Friction, B. Surface tension, C. Viscosity, D. Evaporation. To answer this question, we have to check the options, the meaning of each of the options given to us, and note the one that causes the behavior of the surface of the water in that manner. Option A, we are told, is friction. Friction is the force that opposes the relative sliding motion of solid surfaces in contact. This time, it's not two solid surfaces we are considering. So A cannot be the right answer. A is wrong. Surface tension. Surface tension is the result of the interplay between adhesive and cohesive forces between the container and the liquid. And actually, the surface of the liquid, water, is slightly curved as a result of this surface tension. Option B is correct. Let's look at option C. Viscosity is the force that opposes the relative sliding motion of layers of liquid. There is no opposition, there is no liquid in motion, so it cannot be viscosity. Viscosity, option C, is wrong. Then we have evaporation. Of course, it's not because of evaporation that we are having that effect. There is no change of state of matter. So option D is equally wrong. The right answer is option B. Option B is correct. Example 2. The pressure of a gas, when cooled at constant volume, will decrease because the molecules A collide less frequently with the walls of the container. B have the same average kinetic energy. C break up into smaller molecules. D decrease in number. The answer to example 2 again is obtained by assessing the options given with respect to the statement made. The pressure of a gas is cooled at constant volume. The pressure of a gas, when cooled at constant volume, will reduce. Why must it be so? First, we consider how the pressure of a gas is measured. The pressure of a gas is the number of collisions made per unit time between the gas molecules on one side and the molecules with the container. Pressure of gas is equal to number of collisions made per second between molecules of the gas in that confined space and the container. Now, if the gas is cooled, the temperature is reduced. One thing that will happen is that the molecules of gas will move less frequently, their energy is reduced, and therefore the number of collisions made between them and the walls of the container will reduce. Option A, the molecules will collide less frequently with the walls of the container. Option A is correct. A is correct. B, the molecules have the same average kinetic energy. Kinetic energy is a function of the speed of motion of the molecules of the gas. We are told the gas molecules are cooled, meaning their speed is reduced. Therefore, the kinetic energy cannot be the same. B is wrong. C, the molecules break up into smaller molecules. There is nothing that is breaking the molecules down. C is wrong. D, the molecules decrease in number. Again, there is nothing that is eating the molecules of gas in that container. D is wrong. Option A, by this result, is correct.